Well, we are back with some more biology. Woohoo! Hey, I'm probably going to break this section into a couple of different parts, maybe two parts. There's loads and loads to talk about when we talk about the different eras, and now we're getting into a yet another big time period, although last time we talked about the Precambrian, which actually takes up a majority of our Earth's history. But let's go into some more stuff now. Lovely, right? So today we're going to look at the Phanerozoic Eon. Okay, if you notice, this is again kind of breaking up all of the different time periods. We talked about the Precambrian time period last time. Now we're talking about the Phanerozoic Eon, which encompasses all of these different eras and periods. Now we're going to break this up, obviously, but you'll see we'll talk about the Paleozoic, the Mesozoic, and the Cenozoic. Okay, lots of stuff happens in here. If you notice these, you have the Cambrian time period, Ordovician, Silurian, Devonian, all of these different periods. Okay, and up here, present time is in the Quaternary period. So obviously the Precambrian time period covers a lot of time, but the Phanerozoic era, or eon, covers so much of what we know because there's so much evidence, fossil evidence and such. Okay, so began 542 million years ago. Again, times that we can't even comprehend. 542 million years? Yeah, I can hardly remember 10 years ago, let alone a million years ago, because I wasn't around. So let's talk about the Paleozoic era. People called this the time of ancient life. Some of the life forms that you see in the Paleozoic era were some of the most ancient life forms that we have history on, basically from fossils. So again, 544 to 245 million years ago, bracketed by the two most important biological events in Earth's history. You want to know those? I bet you do. The first appearance of complex organisms. Okay, so you have these kind of very primitive organisms that existed, but now you're starting to get more complex organisms. Also, the largest mass extinction on the history in this Earth occurred during the Paleozoic time. Paleozoic. So basically, those two huge events happened in this time period. Okay. Also, the Paleozoic story explains how early life forms moved from water to land, while the Appalachians existed, while they contained vast coast or coal deposits that fueled industrial revolution. So some big things that basically happened in our time period, we can date back to this time. Okay. So there are seven subdivisions, and I kind of read off a couple of those. I can't talk today. Tongue twisted. Okay, so 7 subdivisions, those periods in the Paleozoic. Cambrian, which is the oldest. Remember last time we talked about the Precambrian, so now we're going to talk about the Cambrian. The Ordovician time period, the Silurian, Devonian, Carboniferous, which is also known as the Mississippian and Pennsylvanian periods, and Permian, which is the most recent. We will talk about each of those briefly. I'll give you guys some examples of what went on there, and then we will move on, okay? So the Cambrian is the oldest of the Paleozoic era. I can never get these numbers right. 544 to 490 million years ago. Why I even say those doesn't matter. I'm not even going to say those anymore. You can read them for yourself. So during the Cambrian period, most of the major groups of those organisms alive today first appeared, which is kind of cool. Some pictures, again, I love to show crazy pictures of what people kind of, well, I'm not going to say they're not made up because these are all based on fossils, but it's cool to see the artwork of people that have drawn these. So kind of cool, kind of scary, by the way. You have the Cambrian explosion. That's a huge event that occurred during the Cambrian period because there was so much diversity that occurred in that explosion. So organisms representing all but one of the major marine groups appeared during the Cambrian period. That's pretty huge, okay? Here's kind of what the seafloor might have looked like. Ooh, ah. I'll show you lots of pictures. So I should like have the little audience clapping in the background. So there's some cool pictures coming up. More of the Cambrian seafloor, you get to see all these kind of crazy creatures. I mean, can you imagine scuba diving and you see like these crazy things? And mind you, most of these are huge. Some of them are smaller creatures, but a lot of these are actually like this big, if not bigger. So kind of crazy. All right, so more on the Cambrian. Basically, you have the development of mineralized skeletons or hard parts that helps mark the beginning of the Cambrian period. So you have a lot of exoskeletons that are starting to develop, which also allow for more fossils. That's why we know so much more about some of the life form that existed during the Cambrian. Here was basically very abundant life form called the trilobites. Okay, and you'll see these even in the Museum of Nature and Science. You'll see a lot of the trilobites, and each of them have their specific names, but they fall under the trilobites. So they're kind of cool. I kind of like. They remind me of roly-polies, and who doesn't like roly-polies? I mean, roly-polies are amazing, right? You roll them up in a little ball, and you can fling them, and then go catch them again because they, have these hard shells. Also, some Cambrian fossils included the brachiopods and the echinoderms. So things like the sand dollars, okay? Brachiopods, starfish, basically were found in this time period as well. So it's kind of cool that those still exist today. Some unique fossils were found in a place called the Burgess Shale, which is in Alberta, Canada. And this guy, Dr. Doolittle Walcott, Charles Doolittle Walcott, it's kind of crazy that he was riding his horse along this area, and I'll show you some pictures coming up, but basically stumbled upon some fossils, and this was a huge area for some of these Cambrian fossils. So contained very unique Middle Cambrian fossils. Here was this place that basically he's riding along. Obviously this is a little bit more present day, maybe in the 80s. I don't know, this person looks like he's wearing pastels. Pastels might be coming back. No, but anyways, kind of stumbled across some fossils, and basically he was the one that discovered so many fossils in this area, in the Burgess Shale. Shale kind of flakes off. It's very easy to actually get to fossils in that area. Here's some more pictures of fossils that came about, some trilobites. I think they're kind of cool, kind of cool to look at. All right, here's some other Cambrian creatures found in the Burgess Shale. I thought this one was really crazy looking. But you can see a perfect fossil right here. Again, kind of one of these weird, crazy sea snake looking things, again, found in the Burgess Shale. All right, so a couple more unique fossils. These animals displayed rapid diversification, okay? Meaning they rapidly diversified. I'm just picking that word apart. When you think about diversity, they became very different very quickly. They only existed for a short time period before they became extinct, okay? And usually a lot of these extinctions were due to glaciation. Glaciation, basically when you have all of a sudden ice covers everything and wipes off any of the, organisms that were living at that time, okay? All right, let's move into the Ordovician period. Most animals alive in the Ordovician were similar to those in the Cambrian. Not a whole lot of difference. But one thing is introduction of the animals similar to the squids, which squids are kind of cool. So we came up with cephalopods, okay? Coral also dominated and algae moved on to land. So kind of the first time you have plants that are located on the land, okay? Kind of crazy looking things. These look like horns. They kind of remind me of squid, but squid don't have these hard kind of exoskeletons. These are a little bit harder. Kind of crazy little cephalopods right here. So those are kind of cool. You also see those in the museum. So take a trip there, and we might take a trip together as well. So by the way, ooh, ah. Okay, here's some more pictures of what the Ordovician seafloor might look like. So now you have a little bit more diversification than the Cambrian, but you still have some of the same things that exist. Look at this crazy octopus looking thing, but it's a big squid, kind of one of these things right there. Okay, so here's some more cephalopod fossils, what they might look like. These are the squid looking creatures. Here's a dime, so obviously these are pretty big. And you have some brachiopods. Again, I'm not going to even attempt to say some of these because I would totally butcher these names, but there's all sorts of different types of fossils found from the Ordovician time. The Earth's climate became much cooler in the middle Ordovician. Glaciers covered much of the continents at this time, and sea level dropped. Here's kind of a funny little comic that I love putting in there. Which part of RSVP didn't you understand? And the world says goodbye to Mr. and Mrs. Unicorn. Anyways, just a little bit on extinction. Climate change probably was responsible for that Ordovician mass extinction. When you have glaciation, obviously that climate is going to cool greatly. Psst, wipe off the organisms that can't survive. 60% of the marine organisms were gone due to that kind of climate change and glaciation. Let's move on to the next time period, Silurian. Okay, the Earth's climate became a little bit more stable and a bit warmer during the Silurian. This allowed a lot of new animals to appear for the first time, like sponges. We have the first jawless fish, sea scorpions, which are kind of cool looking, you'll see. And then coral, lots of coral reefs in this time period. So what is coral? A lot of people don't really understand that coral is actually an invertebrate animal, kind of related to the jellyfish. Okay, we don't sometimes think about coral as an invertebrate, and actually an animal. Small marine animals that live in warm water, okay? And they make a skeleton out of calcium carbonate, okay? They often live in large colonies, but that's what we call reefs. So that calcium carbonate is kind of a skeleton of these corals, which is kind of a cool thing to think about. So next time you go scuba diving or snorkeling, look for those coral. Now you know what they are. All right, so here are some of the coral fossils that we found. Pipe coral, which kind of look like these honeycombs, and then they also formed in reefs as well, and they are now extinct. All right, horn coral, horn-shaped, obviously kind of crazy looking, right? It does look like an actual horn, but it's not. It's a coral. Usually lived alone, so they weren't really reef forming, and those are extinct as well. But those were two of the main corals that were found in that Silurian time period. Some of the fish. You have vertebrate fish, thought to be related to fish with jaws and sharks. They ate through a sucker mouth. Okay, so these are kind of crazy, called the ostracoderm. Okay. All right, these are my favorite, the Eurypterids, the sea scorpions. They kind of look like cute little guys. You know, this is the fossil. You'll see this at the museum as well. They are extinct. They have a feeding appendage in the front that basically helps them feed themselves, related to modern scorpions and spiders. And the funny little FYI fact, it's the NYS state fossil, New York state fossil. So it's kind of weird, you know, the Eurypterid. All right, so there's a little fun fact for you. Some of the Silurian plants would be the Cooksonia. They lived near the shoreline and in shallow water, slowly invaded land by spreading in from rivers and lakes. So these are kind of crazy. They're kind of cool looking though. But these were some of the early plants that you were ever to see on land. Okay, moving on to the Devonian time period. All right, we call this the Age of the Fishes. I love this picture because it looks really freaky. I can't imagine, you know, this lake looking super pretty from above, and then underneath you see these crazy looking fish. Okay, the placoderms, again, very crazy looking fish, the first of the jawed fish. There's a picture of this in our museum as well. By the way, like I said, I will be getting a field trip going, so be looking for that email coming up. All right, placoderm, so kind of crazy looking jawed fish, look very evil and scary. I don't know, I'm sure they ate lots of big fish as well, but nonetheless, those are some of the big things that came about. Also, the first appearance of real trees. Okay, before you had maybe kind of some plants, some little bushes, but now we have real trees. Most vegetation were small plants. Tallest plants were only about 3 feet tall, but nonetheless, so it's not like I actually say this is not really an accurate picture because you didn't have trees that were this tall in the Devonian time period. They were smaller, maybe 3 feet, okay? All right, so Devonian trees, most were shorter than 1 meter tall. These are kind of those Cooksonia, but also they started developing into a little bit taller of, not necessarily the trees that we know of, but more taller bushes. Ferns, horsetails, and seed plants became common in this Devonian times. That's a big thing, that seed plants. So a different way of reproduction. The first forests became present, but not that they look like our forests, okay? And then Rhynie chert fossils. This was a big thing in the Devonian time that you found these Rhynie chert were a type of fossil that were very abundant during the Devonian time. Okay, and they were discovered, I don't know how many years ago, but that was a big discovery. Also, you have the first amphibians during this time. Woohoo! That was kind of a cool thing. All right, and then here's what an early amphibian fossil might look like from the Devonian time. So, kind of goofy looking, right? All right, and then the first wingless insects. Interesting. So you have the cockroach and tarantula kind of looking creatures, very similar to what we would find in the Devonian time period, okay? Some of those arthropods that started coming about. And then you have this lovely extinction that happens once again. That darn glaciation, some kind of impact, basically wiped out much of the marine life, especially those that lived in the warm water, because obviously if something was used to warm water, it couldn't deal with the colder climates, colder water temperatures. Okay. Now let's move on to the Carboniferous. Okay, subdivided into the Mississippian and Pennsylvanian. Lots of swamps and actually lots of coal started to form. That's kind of why it got its Carboniferous, because coal is made of carbon. The first reptiles came about in this time period, and major biological revolution during this time period. The hard-shelled egg. That was a big deal. That was a good way to protect young. okay, were laying eggs. So that was a good kind of movement towards, what we see today. So here's kind of what the Carboniferous forest might look like. You have trees that are growing a lot taller, but I'm not saying that it was all black and white, but you would see a lot more black in this time period because there were a lot of carbon and coal formations and deposits. Okay. Here are some of the plant fossils that you would see at this time. Lovely, some ferns. Okay, and then some of the reptile fossils. They can live on land or in water, and they have that amniotic egg or a shell that allows animals to reproduce on land, which was a great thing. Kind of a good evolving to more complex creatures. Okay, the embryo in this amniotic egg surrounded by a liquid sac, we call that the amniotic cavity, protected or provided with food source, that yolk, and a water sac. And the evolution of the amniotic egg allowed reptiles to inhabit all parts of the land because they no longer had to return to the water to basically give birth or reproduce. So that was kind of a big deal. All right, now, the Permian time period. This is the last period of the Paleozoic. It ends with the largest mass extinction in the history of the planet we live on. Most affected, the animals in the ocean, of course. By the way, not too much difference in that seafloor, but you can see there are some different kind of things coming about in the Permian time period. Now you have some reptile fossils. I like these Dimetrodons. Again, there's, I think, one of these in the museum, so it's kind of cool to see these up close. But this is one of the reptile fossils found in the Permian time period. You have different types of slightly looking, dinosaur-looking creatures, but they're more reptiles at this point. We didn't really talk about the dinosaurs until the next part we're going to get into. Okay, but here are some of the creatures that we might have seen during that time. Okay, so the end of the Paleozoic, the largest mass extinction in Earth's history. 90 to 95% of all marine species became extinct. Kind of crazy. Likely due to changes in the environment, competition for living space, colder climate, maybe a volcano eruption. So there are a lot of theories of why this basically happened and occurred. So these mass extinctions, referred to as the mother of the mass extinctions, was the late Permian extinction. 90% of all pre-existing marine species disappeared. On land, spore-bearing plants gave way to conifers and gymnosperms. Those kind of continued on. Vegetative change causes chain reaction in land animals. So lots of change occurred during these mass extinctions. Many families of the basal tetrapods, which is just one of the primitive reptiles, or one of the organisms, along with primitive reptiles, they basically disappeared. Okay, so kind of, I'm not going to say sad because it's just what happened, but it's crazy that all of these life forms, you had that Cambrian explosion, and all through these different periods and time periods, you get all this diversification only to have it wiped out. So it's kind of interesting. Now let's talk about what happened with our continents, and then we're about done here. 6 major continents were present at the beginning of the Paleozoic era. Okay, so kind of 6 major continents. So we looked at back to, let's see, kind of the change. Here's present day. Sorry, I have to read really close because I can hardly see. But it's talking about the different movement of the plates. So basically, the plate movement during the Paleozoic resulted in continental collisions. So you have these continents that collide with each other, leading to the formation of the supercontinent that a lot of you guys know of as Pangea. So Pangea is kind of what this looks like right here, where you have continents, like we call these little continents. They weren't what we have today, but then through this time period of the Paleozoic era, you have this crashing of these plate tectonics and these plates that are crashing, and then all of a sudden you have this huge, massive continent. Now again, that continues to happen over time, and obviously we end up with what we have present day. But during these time periods, all of these plates are kind of crashing together, and the formation of the land looks very different over the time period. Okay, so again, a closer look at Pangea. So basically, at the end of the Paleozoic time period, this is kind of, or throughout it, you have this Pangea, which is what kind of it looked like. Okay, so that's a lot to take in, and a lot of makeup here, so I like to kind of, too much of this stuff. So I don't want to overload you guys. I went over the basic concepts of each of those time periods. Please go back into your lesson, go over some of those big, concepts, go over some of the details that you find in there, put it all together, make sure you guys are kind of taking notes on all that stuff. You don't necessarily have to take notes on this, but you can. Never hurts. But make sure that you are taking notes on your lesson and coinciding that with these mini lessons so that you get to understand the big picture and all those details. Okay, well that's it for now. We'll come back with some more details of the time periods. Bye-bye.